Thanks for coming here to watch the first OLNA lesson. You'll find a number of questions here involving conversions of units, some questions with fractions, and another question involving the volume of a rectangular prism. There are lots of different skills and questions presented on our YouTube channel which will assist you with your OLNA, and it would greatly assist us too if you subscribe to our channel. Thanks very much, and we hope you get great benefit from what's coming up. One of the tasks that often comes up in OLNA assessments is the ability to multiply by powers of 10, such as 10, 100, 1000, and also being able to convert between units. In this case, we're converting between units of length, such as kilometres, metres, centimetres, and millimetres. Now, this is shown in a video on our YouTube channel in more detail, but what we'll do is we'll quickly go through a chart that we can set up and use when we're doing OLNA questions. Now we need to make sure we have a basic understanding that 1 kilometre is equal to 1,000 metres. So what we do on our chart, from where we have an arrow going from kilometres to metres, we place multiply by 1,000. In other words, whatever number of kilometres we've got, we're going to multiply that by 1,000 to get the number of metres. Likewise, there's 100 centimetres in a metre, so we multiply by 100 when going from metres to centimetres. And then we multiply by 10 when going from centimetres to millimetres. Now, going in the reverse order, in other words from millimetres towards kilometres, we're going to do the reverse operations. So it's divide by 10, divide by 100, and then divide by 1000. It's suggested that you pause the video here and see if you can complete the table for yourself. Let's have a look at the solution now for these conversions. So the first one is in metres. So according to the chart, to go to centimetres, we need to multiply by 100. So 1 times 100, it's quite a simple calculation, that'll be 100. Now to go centimetres to millimetres, we start at the centimetres and we need to multiply by 10. So 34 multiplied by 10 would mean that we need to place an extra 0 at the end of that number. So 340 millimetres is the answer. From centimetres to metres, we need to follow the arrow across, and this is dividing by 100. So 500 dividing by 100 is a simple calculation, because when it's 100 we can cross off the zeros and we're left with 5 metres. 6,000 metres to kilometres means that we go on the chart on the blue number there, which is to divide by 1,000, and 6,000 divided by 1,000, again a simple calculation because it means dividing by 1,000, which means crossing off zeros. So we're left with 6 kilometres. 950 centimetres to millimetres, according to the chart, would mean to multiply by 10. So 950 multiplied by 10 means we can place an extra 0 at the end. So the answer is 9,500 millimetres. And finally, to go from centimetres to kilometres, according to the chart, means we need to make 2 jumps. We need to divide by 100 first of all. So 230,000 divided by 100 means we can cancel 2 zeros, and we're left with 2,300. And then the next jump would be to divide by 1,000. So dividing by 1,000, we can cross off 2 zeros here, but in the next case, when we cross off that 0, we have to move a decimal point. So it becomes 2.3 kilometres. Having this chart in front of us makes these calculations quite straightforward. So it's strongly recommended that you practice making sure that you understand this chart and being able to rewrite it in an OLNA assessment so you can use it to do calculations like these. Let's look at some more conversions, this time involving mass. So what would be recommended that you pause here and attempt the task, but do so with a conversion chart which you can create for yourself between milligrams, grams and kilograms. So we've got our conversion chart starting with kilograms on the right, and 1 kilogram has 1,000 grams, so we need to multiply by 1,000, and 1 gram has 1,000 milligrams, so we need to multiply by 1,000 to do that conversion. And the conversions going the other way, so milligrams to grams, is the opposite. We're going to divide by 1,000, and then grams to kilograms divide by 1,000 as well. So let's have a look. 4 kilograms to grams means we need to multiply by 1,000. So 4 multiplying by 1,000 means it's just a case of placing 3 extra zeros at the end, because 4 times 1 is 4. So we get 4,000 grams. Grams to milligrams is also multiplying by 1,000. So 30 multiplied by 1,000, we know that 3 times 1 is 3, and there are 4 zeros that we need to place. We get an answer of 30,000 milligrams. To go from milligrams to grams, we need to divide by 1,000. So it's 1,200 divided by 1,000. That gives an answer of 1.2 grams. That's something you may want to check if you're not comfortable with division. In the next problem, we've got grams to kilograms. So this also involves division by 1,000. So we've got 50 divided by 1,000. What we can do is when we've got numbers with zeros and we're dividing, we can cancel 2 like that. And there are 2 zeros left in the 100. That means that we're going to move the decimal point from the 5, which is on the far right, 2 places. And if we do that, what we've got is 0.05. Again, this is something you may want to check if you're not comfortable with division. In the next case, we're going from kilograms to grams. That means we're multiplying by 1,000 again. So 0.4 multiplied by 1,000 can involve a couple of steps. What we can do is cross off that 0 and show the decimal point moving 1 place to the right, making the number larger. Now it's 4 multiplied by 100, and that's a lot easier because we can place 2 zeros at the end of the 4 and get 400 grams. And lastly, we're going from kilograms all the way to milligrams. That's 2 steps, both involving multiplying by 1,000. Let's multiply by 1,000 first of all. And we can see that decimal point is going to move 3 places because there are 3 zeros in 1,000. And we've got an answer of 5. So that's the first multiplication. And then we do it again. 5 multiplied by 1,000. We're going to place 3 zeros at the end of the 5. And we get 5,000 milligrams. Again, we can see here that having an understanding of these conversion charts for mass and for distance and for things such as time are very useful to help us do calculations like these quickly. Coming up now is a question where we'll apply these conversions, so it's suggested that you pause here, read the question coming up, and have a go at this question before you see the solution. After we've read a word question once, we then need to look for the key words that are going to help us answer the question. Sum is one of them. That tells us to add the amounts, and we need to give our answer in centimetres. Now when adding any units, we do need to make sure that they're in the same units. The answer is telling us they should be in centimetres. So let's look at a conversion chart. We've got millimetres as our smallest unit, and then centimetres and metres. And we know that there's 100 centimetres in a metre, so that means that 1 metre, we need to multiply it by 100. And centimetres to millimetres is multiplying by 10. In reverse, we're going to divide by the same numbers. So our first amount is 2 metres. Looking at the chart, we need to multiply by 100. So we'll put down 2 multiplied by 100, and that gives us 200 centimetres. We need to convert 20 millimetres to centimetres, and we do that dividing by 10. So 20 millimetres is equal to 20 divided by 10, and that's just 2. And we'll put centimetres there. So our final amounts have to be added up to get the sum. And those amounts are 200, and we've got 28, and also 2. They're the different amounts in centimetres. When we add those up, we get 230 centimetres. Coming up is another conversion question, so a good idea would be to pause here, have a go at the question before you see the answers. So the key part of this question is asking for 1/3 of something. Also it wants the answers in centimetres. Now 1/3 of something can be calculated by dividing by 3. If we break things into 3 parts, that will give us 1/3. So a simple example we know that is 1/3 of 3. And 1/3 of 3 is just equal to 1. We've broken 3 down into 3 parts, 1 each. So to work out 1/3 of 6.3, the simple way to do it is to divide 6.3 by 3, again breaking it up into 3 parts. And we'll show that with a division problem. So 3 going into 6.3. We know that 3 goes into 6 twice, no remainder. We've got a decimal point there. And 3 goes into 3 once. So 1/3 of 6.3 metres is equal to 2.1 metres. But our answer has to be in centimetres. So we'll do a little conversion chart between centimetres and metres. 1 metre we need to multiply by 100 to convert to centimetres. So 2.1, we move the decimal point 1 place when multiplying by 10, and then a further 0 when multiplying by 100. And our answer is 210 centimetres. Okay, another opportunity to pause and have a go at a question before we have a look at the solution. Let's have a look at some of the keywords in the question. The first thing we'll notice is our answer has to be in millilitres. That's mentioned in the very first line. We know we've got a jug with 3 litres of water, and we're going to pour 3 glasses out of it, each of 250 millilitres. So let's first of all look at what 3 glasses worth of 250 millilitres would look like. So we know how many millilitres has been poured out of the jug. So we're going to do a multiplication. 3 zeros are 0, 3 5s are 15, we'll put down a 5, carry the 1, 3 2s are 6, add the 1, makes 7. So that's 750 millilitres of water has been poured out of the jug. That's what's been left. We need to work out what's still in the jug. Now to do that we need to convert our units. So from litres to millilitres, that's a multiplication by 1000. So 3 litres of water in the jug will equal 3000 millilitres of water. So now what we need to do is work out how much water is left behind if we've poured out 750 mils. That's going to involve a subtraction. So to do that now, we'll look at the columns as you normally would for a subtraction. 0 take 0 is 0. 0 take 5 can't be done, and we can't borrow from the next column as it is, because that's also a 0. So we're going to have to borrow from the thousands. What happens now is we're left with 10 minus 5 in that second column. Then 9 minus 7 is 2, and 2 minus nothing is just 2. That gives us 2,250 millilitres of water left behind in the jug. And we'll leave that in millilitres because that was what the question asked for. This is another opportunity to pause before we have a look at the next question. Let's once again look for the keywords in the question. We want to add these amounts, so we're looking at a sum, and we want to give our answers in grams. So one of them is already in grams, so that's okay. We need to convert the other two, so we need to do a conversion chart. As usual, we'll put the units down with the small units on the left, and to go from kilograms to grams we multiply by 1000, grams to milligrams multiply by 1000, and in reverse do the opposite operation, so divide by the same amounts. So the first one we'll look at is for kilograms. And if we go to our chart, we can see here that that involves multiplying by 1000 to get it to grams. So 4 multiplied by 1000, we know 4 times 1 is 4. And then we place an extra 3 zeros at the end. So that's 4,000 grams. 4,000 milligrams, we need to divide by 1000 to go to grams. So 4,000 divided by 1000, we can cancel the zeros there. And if we do that, we're left with an answer of 4 divided by 1, which is just 4. So that gives us 4 grams. So now what we'll do is we'll add up those amounts. We've got 4 kilograms, which is 4,000 grams, 400 grams, and 4 grams for the smallest amount, which was originally milligrams. And if we add those up, just doing a normal sum, we get 4,404 grams. This is another opportunity to pause before we have a look at the next question. So again, looking at some of the key words, we want a fraction of a dollar if we've spent 20 cents of that dollar. Okay, so we need to convert them to the same units. $1 is equal to 100 cents. And if we spend 20 cents, we're going to take that away. And that's leaving us with 80 cents. So we want the amount we've got left as a fraction of $1. So the fraction left is equal to 80 over 100. Now that can be simplified because when dividing by 100 we can cross off matching zeros at the end of the number. Also 2 goes into 8 4 times and 2 goes into 10 5 times. And that's the simplest fraction. So the fraction we have left out of $1 is 4/5. This is another opportunity to pause before we have a look at the next question. So looking at some of the key words for this question, what we want to do is find the fraction of the pie we've eaten, so what's been taken away. Our first piece we ate was 1/6 of the pie, and the second piece was 1/10 of the pie. So what we need to do is work out how much of the pie we've actually removed or eaten. That's 1/6 plus 1/10. Now when we add fractions, we need a common denominator. At the moment there's 6 and 10. Now we could multiply them. 6 by 10 is 60, but we know that 6 and 10 both go into 30. Okay, that's the lowest common denominator. Now to change 6 into 30, we need to multiply by 5, so we do the same thing on the top. 1 times 5 is 5. To change 10 to a denominator of 30, we need to multiply by 3. And 1 times 3 is 3. So adding those together, we get 8 over 30 because we add the numerators. And we can simplify that. 2 goes into 8 4 times, and 2 goes into 30 15 times. Now, a lot of people find fractions quite difficult, so it would be wise to go back and review this solution if you're having troubles going through and simplifying and adding your fractions. This is another opportunity to pause before we have a look at the next question. The key thing to note here is if we're working with fractions and percentages, percentages are just a fraction over 100. So 25% is just 25 over 100. And a lot of us are familiar with the fact that 25% of something is a quarter. But what if we weren't so sure about that? How do we simplify to show that 25 over 100 is equal to 1/4? Well, 25 and 100 end in a 5 and a 0. 25 ending in a 5 and 100 ending in a 0. That means 5 goes into both of them. 5 goes into 25 5 times. We know that 5 goes into 10 twice, and it goes into 0 0 times. So that's 5 over 20. We can simplify that to 1/4 because 5 goes into 5 once and into 20 4 times. Let's look at 60%. That's just 60 over 100. Now we can cross off the matching zeros at the end because that's like dividing by 10, and we've got 6 over 10. And we know that 2 goes into 6 3 times and 2 goes into 10 5 times. That's as simple as it can get. So the simplified answer there is 3/5. This is another opportunity to pause before we have a look at the next question. So for the first question, we're asked to work out the volume of a prism. In this case, it's length times width times height because it's a rectangular prism, or just basically a box. And we can see from the measurements here that we've got a length of 8 centimeters at the front, the width is 4 centimeters at the side, and the height is 5. Now the easy way to multiply those together without a calculator is to go 4 times 5 first, because we know that ends in a 0, it's 20. So our problem becomes 8 multiplied by 20. Now 8 times 2 is 16, and then we place a 0 at the end, so it gives us an answer of 160 centimeters cubed. It's cubed because we're counting little cubes inside the box when we determine a volume. Now we know that 1 litre is 1,000 centimeters cubed, and 1 litre is 1,000 milliliters. So that also equals 1,000 centimeters cubed, and that means there's a perfect match. millilitres and centimetres match. 1 millilitre is equal to 1 centimetre cubed. So 160 centimetres cubed is also 160 millilitres. And that's the required amount of water. Thanks again for watching. Please don't forget to subscribe to our channel and have a look at our YouTube channel and our website for different resources that will help you to get through your OLNA.